Hello, and welcome again to FlippedHarber for Algebra 2. In this video, we're going to cover Section 1.5, Properties of Exponents. Our objectives for this lesson are to simplify expressions involving exponents. And we're also going to try to figure out how to use scientific notation. In this video, we're going to start by looking at expanded form. We're going to look at zero and negative exponents. We're going to look at some properties of exponents. We're going to talk about how to make and use scientific notation, and then we'll go over some examples. Now, expanded form basically means that we write out everything with a power, the number of times indicated by that exponent. Now, you need to pay close attention to negatives and parentheses. Those parentheses are going to tell you what is actually getting the power. So we've got a few examples right here. In our first one, negative 2x cubed, with no parentheses, that means that only the x is getting cubed. The negative 2 just happens once, and then we multiply by x times x times x. In the middle example, because of those parentheses, now the 2 is getting cubed along with the x. The negative is not, because it's not inside the parentheses. So in expanded form, the negative sits there in front. It happens once, and then 2x times 2x times 2x. In the last one, in the bottom one, now everything is inside the parentheses. So that means that the negative is getting cubed along with the 2, along with the x. So we see the whole thing, negative 2x times negative 2x times negative 2x, 3 times. Really, expanded form is all about making sure that you know what's getting the power and what's not. Now let's talk about zero and negative exponents. Whenever you see a zero exponent, whether that zero exponent is on a number or on a letter, a variable, it equals 1. We'll talk about why in a second. Whenever you see a negative exponent, not that we hate negative exponents, but we like to get rid of them when we can. That negative exponent to me is saying, hey, this number or this letter is in the wrong spot. What I mean by the wrong spot is it's in the wrong spot in the fraction. So if we put it in the right spot, that negative goes away. So we see 7 to the negative 2 power. That negative is telling me the 7 is in the wrong spot. If I move it to the right spot, it turns to a positive 2. So that right spot is in the bottom of the fraction. If we see a negative exponent on an entire fraction, like 3/2 to the negative 4th power, that means that both the top and the bottom of the fraction are in the wrong spot. So if I flip them, I can go ahead and get rid of the negative. So it becomes 2/3 to the 4th power. Now, here's some properties of exponents. And really, these are just talking about how well exponents work with multiplication and division. Since exponents are basically a form of multiplication, it works great with multiplication, it works great with division, not so much with addition and subtraction. But here's some properties. If you have the same base number or the same base letter multiplied together, you can add the exponents. So 4 cubed times 4 squared, because they're both 4, we can add the power. It becomes 4 to the 5th power. Now, something very similar happens if we're dividing, but since division is the opposite of multiplication, we're going to do the opposite of addition. We're going to subtract. So 3 to the 7th power divided by 3 squared, we subtract the powers. Now we're going 7 minus 2 because 7 is the top power. Don't worry about which power is bigger, which power is smaller. It's always top minus bottom. So we get 3 to the 5th power. A power to a power, like 4 cubed quantity squared. We can go ahead and multiply the powers. So 3 times 2 gives us 6. So it becomes 4 to the 6th power. Last couple deal with if you put the power on something bigger, if you put a power on multiplication, if you put a power on a fraction, you can break them up. Instead of 3 times 4, all of that squared, maybe it's easier to make it 3 squared times 4 squared. You get to do that. Instead of 3/5 squared, you can break it up and square the top, square the bottom separately. all of these properties also work with variables. Nothing in algebra is specific to just numbers or just letters. All of these rules can be applied equally well to numbers and variables. Now, I don't know why nobody ever asks me. Everybody's just totally willing to agree with me. Yeah, 0 power, it's equal to 1. Nobody ever asks me why. I don't understand that. If you really want to understand this stuff, you've got to start asking yourself, why does it work that way? Well, here's a way to explain it. A way to get a 0 power would be through division. If we take x cubed divided by x cubed, what we just saw about division, we get to subtract those powers. Well, it doesn't take a rocket scientist to figure out that 3 minus 3 is 0. So we just created a 0 power. Let's go back up to the top. X cubed divided by x cubed. Well, that should equal 1. Whenever you take something, divide it by itself, you get 1. Well, if x cubed divided by x cubed is going to equal 1, that means x to the 0 power must equal 1 also. So there's why a 0 exponent equals 1. Let's talk about scientific notation. Scientific notation was really created for two reasons. One, it makes writing really, really big and really small numbers easier. It literally takes up less space on the paper. But more importantly, it's actually easier to multiply these numbers or divide these numbers when they're in scientific notation. It was very important back in the day before the fancy calculators that they needed to make this multiplication or make this division easier. Now, scientific notation is always made up of a base number multiplied by 10 to some power. Now, that base number needs to be between 1 and 10. Here's a rule of thumb for you. If that power on 10 is positive, it's a big number. If that power on 10 is negative, then it's a small number. Now, this is one of those few cases where we're absolutely fine with negative powers. Don't think you have to do anything weird because the power is a negative number in scientific notation. And if you really want to make this easier on yourself, know how to use scientific notation on your calculator. If you don't know how, that would be a great thing to ask me when I'm going around the classroom group to group. If you don't know how to use scientific notation on your calculator, please ask. It will make your life so much easier. Not just in this class, but in chemistry, in physics, in science altogether. Now, let's actually create some scientific notation. I've got two numbers here. A big number, 1,320,000, and a small number, 0.0000045. In both of these cases, I'm going to turn these into scientific notation by moving the decimal. And I'm going to move the decimal so that there's one number in front and however many after, I don't care. But it needs to be one number in front of the decimal because that's going to make it between 1 and 10. In both of these cases, I have to move the decimal 6 spaces. But I'm moving them in different directions. The one on top, it's going to move to the left. One on bottom, it has to move to the right. Now, once I move that decimal, I'm going to have 1.32, and then since I moved it 6 spaces, that's going to be my power on 10, is a 6. In the bottom one, I get 4.5, but since I moved the decimal in the other direction, it's a negative 6. And again, my rule of thumb, positive power on the 10, big number. 1,320,000 is a big number. 4.5 times 10 to the negative 6, that's not a big number. That's a little tiny decimal. Pay attention to that rule of thumb. Now, multiplying by with scientific notation. This is really why it was invented, was for multiplying these numbers, for dividing them. If these were in their standard long form, doing this multiplication would be a pain in the butt. But it's actually easier when it's in scientific notation. I'm going to regroup these numbers. I'm actually going to take the 2.1 and the 3.3 and group them, and I'm going to group the powers on 10. So, regrouping, I've got 2.1 times 3.3. In the back, I've got 10 cubed times 10 to the 5th. 2.1 times 3.3, well, that's 6.93. That's not difficult. 10 cubed times 10 to the 5th, all I got to do is add the powers. I get 10 to the 8th. So now I've got scientific notation. Great. Always make sure that this base number is between 1 and 10. 6.93, yeah, that's between 1 and 10. Let's take a look at what happens when that number is not between 1 and 10. I'm going to tinker with that first number a little bit. So it's now 5.4 times 10 cubed. Again, I'm going to regroup the 5.4 times the 3.3. That gives me 17.82. The 10 cubed times the 10 to the 5th, that still gives me 10 to the 8th. But I've got a problem. 17.82 is not between 1 and 10. So I'm going to move the decimal one spot to the right, to the left, and that's going to raise my power on 10 by 1. You're going to save yourself a whole lot of trouble if you can just do this on your calculator. Ask if you don't know. Dividing with scientific notation, very, very similar. We're going to worry about the 8.4 and the 2.1, and then we'll deal with the tens. So 8.4 divided by 2.1, that's 4. No big deal. Dealing with the tens, we're dividing, so we subtract the powers. -3 minus -5. Minus a negative becomes addition, so we get 4 times 10 squared. Let's do some examples. Now remember, these examples are great notebook quiz questions. Write these down. Now we want to write this first example in expanded form. Pay attention to what's getting cubed. The negative is not getting cubed. Is the 4 getting cubed? Yeah, it's in parentheses. So that 4 gets cubed with the y, so we have negative 4y times 4y times 4y. Let's look at the next one. Is the negative getting cubed with the 2? Absolutely. It's inside the parentheses. What about the x? Is it getting cubed? No. It's got its own power. So we get -2 times -2 times -2, and then that's followed by 4 x's multiplied together. Again, the idea here is you showing that you know what the power is acting on. Let's take a look at some negative exponents. Now this first one is just 10 to the -2. It's not scientific notation. We're not thrilled with the negative. So that negative is telling us, hey, move it to the right part of the fraction and it's going to be positive. So I move the 10 from the top of the fraction down to the bottom. It's now a +2 exponent, and I go ahead and fix it so that 10 squared is equal to 100. So my final answer is 1 over 100. Let's take a look at the one on the right. That negative exponent is acting on the entire fraction. That means that the 2 and the 3 are in the wrong spot. So the first thing I do is flip them. So now it's a positive power. And I go ahead and cube the 3. That's 27. I cube the 2, and I get 8. Now, let's take a look at simplifying some expressions. Basically, we're going to multiply together and combine what we can. So the -2 and the 7 multiply to create a -14. S to the -3rd power times s to the -8th power, well, we add the exponents, we get a -11. T times t to the 5th, we add the exponents, we get t to the 6th power. The only thing to fix here is the negative power. We don't like those. So we're going to push the s down to the bottom of the fraction, leave the -14, leave the t to the 6th power. Just move the s term, and now the power is positive. Looking over on the right, got a lot of stuff. We're going to combine the x's by subtracting the powers. We're going to combine the y's by subtracting the powers. Or you can just move stuff around to make those negatives positive, like I did here. So all the powers are positive. So now I just combine. What needs to be combined? Well, the x squared and the x, those can combine. The y to the fifth over y cubed, some stuff can cancel. So I get y squared over x cubed. Here's an example where I have some to multiply with scientific notation. I'm going to regroup 2.2 times 4.5 and the 10 to the 5th times 10 to the 11th. 2.2 times 4.5 is 9.9, right on that edge. It's between 1 and 10, but it's almost there. Times 10 to the 16th. It's all set. Let's divide once more with scientific notation. We're going to take the 16, divide it by the 4, and then we'll deal with the tens. 16 divided by 4 is 4. 10 to the negative third power divided by 10 to the fourth power. I subtract the powers and I get 10 to the negative seventh. Since it's in scientific notation, that negative power is okay. Okay, honestly, if you can just plug these into your calculator, you'll be fine with scientific notation. Make sure you know how to use scientific notation on your calculator. That is very, very important. Okay, so that's basically it. Here's the homework for the section. You should already have this, so you should be all set to go. So we're all done with this video, and I will see you in class, and I'll see you in the videos.